Hmm. Hi, welcome back to Math Learning Groups, and today we are going to continue with our speed lessons. So far, what have we learned? We have learned about how to draw a one-part journey and also a two-part journey, and how do we find the distance, and how do we find the time and the average speed. All right, so today we are going to look at what do we do when we see fractions. All right, fractions in the problem. So what do we do? Do we draw the bar model when we see fractions, or do we cut the journey into so many parts? So we are going to look at this area in our lesson. So let's look at the question. A motorist traveled two-thirds, which is talking about his journey. So in our fraction lesson, I will usually tell my students or teach them, when you look at fractions, what do you think they are talking about generally? So the two-thirds is generally talking about his journey, right? It's talking about a group or something. So you have to look at what's behind the of. So of what? Of his journey. And so he traveled two-thirds of his journey at the speed of 80 kilometers per hour and completed the remaining, right? Completed the remaining journey. So again, you can see that if you have the word average speed, so it means what? It means that you can actually ignore the word average because it's the same as travel at the speed of 80 km per hour. So you don't need to look at the word average, right? It's like redundant, right? The word is actually not important. So completed the remaining journey, which is 240 kilometers in 4 hours. So what was the total time taken for the whole journey? So when you look at this problem, you will need to ask whether is it a one-part journey or is it a two-part journey, and how is the motorist moving? Right, the motorist is moving this way, right, from left to right. So do I cut the line into three parts? Now, this is one of the areas which some teachers they will do that, they will cut the three parts. But I will not do that because what happens if the denominator is very big? Then you have to cut into many parts. So there is something that we can do over here to make it easier. So I will still have a two-part journey because this is the first part, which is the two-thirds of the journey. And then he completed the remaining journey, which is the second part. So what have we learned the last few lessons? Every part of the journey has a family. So you have speed, distance, and time. And the second part, you also have a speed, distance, and time. And there is a boss. Okay, a boss family that oversee the entire model. All right, and then you also have the labeling, who is traveling. So you still have a two-part journey. But what do we do with the fractions? This is what we do, right? Now, the motorist traveled two-thirds, which is talking about the distance. So I will actually put the two-thirds, the entire fraction. I will put the fraction into the model. And if there's a two-thirds, then there is a one-third. And if there's a two-thirds, there's a one-third, then there is a three-third. So there is a family of fractions. So in other words, there will be 2 units for the first part, 1 unit of distance for the second part, and the total distance is actually 3 units. And the speed will be 80 km per hour, and the remaining journey is 240 km. That is the second part, and the 4 hours will be over here. So that's how you fill in the blanks. And what's the total time taken for the whole journey? And that's your question mark. Right, and your model is done. So what is a good model? Now, a good model is when you don't need to look at the question and you are able to still able to solve it efficiently. So you will need to know your triangle. So we're going to revise the triangle. So there's a distance on top and there's a speed and time. So you look at the model. Common mistake, right? One of the common mistake is when students learn about this way of doing, what they do or what they continue to do is they will want to find the time, which is the first part. And the common mistake is they take distance divided by speed. And that is the common mistake, which is not correct. And why is it not correct? Because when you write your steps, I did mention that you will need to put your units there, right? So that you can check to see whether the units are the same. So why is this statement wrong? Because if you look at the two-thirds, it is not the actual distance. There is no unit there. No unit. So how do you divide? How can you divide when there's no unit? So that's the reason why you cannot take two-thirds divided by 80 kilometers per hour, because it's not the actual distance. It is a representation. So we can't do this way. And that is something that you should be aware so that you don't make the same mistake when you do this, when you draw this model. Okay, if you look at the model, you will be able to see that 1/3 or 1 unit, 1/3 is 240 km, and therefore my 2/3 must be 240 times 2, that will be 480 km. And that is the distance for the first part. Alright, now you can find the time. So the time is equal to distance, which is 480 kilometer divided by speed, which is 80 kilometers per hour. So you have to check before you divide, you need to check whether the units are the same. And if they are the same, then you divide and you will get 6 hours. And you put down over here. So the time is 6 hours for the first part. So can we find the total time taken? So you take 6 plus 4, and that gives you 10 hours. And you got the answer already, right? Which is quite fast. And of course, do I need to know the speed, the average speed for the whole journey? Do I need to know the entire distance? You don't have to know. So when you get the answer already, you can move on to the other question. So there's no need to find everything, because if you find everything, you are just wasting time in the exam. So you will need to be efficient, right? Once you get the answer, and then that's it. All right, so no need to find the other blanks. And that's how you put fractions in the model. So I don't cut the model into 3 parts, because if the denominator is big, then you have to cut into many parts, and it's going to be a bit complicated to put all these families, all these speed, distance, and time into your model. All right, so stay tuned for the next coming lesson. Now, in the next coming lesson, we will talk about speed increase and also about speed decrease. And before we end this video, I will also like to mention about what happens if it's a percentage, right? If the fraction is not a fraction but it's a percentage, then what you will do is, if it's a percentage, you just have to change it into a fraction, and you will get 20 over 100 or 1p. So and then everything will be the same. So if it's a percentage, if it's a fraction, then you just change it to if it's a percentage, then you just change it to fraction, and then everything will be what you have seen in the video. All right, so see you in the next lesson. In the next lesson, we will talk about speed increase and also speed decrease. All right, so what do you do when you increase your speed, and what do you do when you decrease your speed? All right, see you in the next lesson.